Hello. Today on 26.1 AI Podcast, we have with us Andrea Brice, founder of Afterwards, and also BI architect at Busy Solutions. For me personally, Andrea, I believe, was one of the attendees at one of my first meetings for Puppy in Seattle when we met at Facebook for a women's mini conference. Um, I invited Andrea after seeing some comments she had made on LinkedIn that were a little more skeptical about AI and data science than some of our previous guests have been. Welcome, Andrea.
Andrea, Andrea, welcome. It's so good to have you on our podcast. And it sounds like you have a very long background that led you to being here today. Can you give us a little bit of that history?
Yeah, I started working with data acquisition, data cleaning, tidying data off of a 1.2 kilobit modem in 1989 as a field tech for McCaw Cellular One. I had a 25-year career in wireless telecommunications, network planning and engineering, and my final position was as principal engineer at AT&T Mobility, where I helped negotiate algorithms between AT&T and Ericsson, Nokia, Nortel, Alcatel-Lucent to quantify, measure, and report on the core network, voice and data networks. So my algorithms impacted contracts for availability. And so all my algorithms were actually peer reviewed up to the executive level. So I helped scale what's now called data science or big data at AT&T through my engineering practice.
Yeah, and 1989 was when I bought my very first cell phone. So that's a nice coincidence. I think I was a McCaw Cellular customer then. But you're bringing up some job titles, and one thing I've mused about in a previous episode is the job title data engineer, for example, and maybe explain more about what your views are on these new job titles and what their descriptions are, and kind of the mismatch you see coming from engineering practices that are probably more rigorous than many modern software professionals deploy or apply.
Well, one of the things that startled me when left, I retired from AT&T Wireless in I think November 2014 because the outside world finally got interesting enough. There are very few people that can say they had an entire industry grow up around what they were passionate about, and mine was data acquisition for creating some interesting algorithms and being able to see what was happening with our voice and data networks, which is the reason why we could actually scale and support things like the fact that our wireless telecommunications networks often had data speeds faster than the landline connections that were available at the time. But things like data engineer, the fact that it's only now becoming something that's being introduced into business practice is kind of shocking to me. My desktop server was a server in the mid 90s, and so I was the one pulling the data from the 51 Ericsson switches in the AT&T Wireless network at that time. We were scaling the data so big, though, that when an enterprise IT organization came and asked me if I would give them my code to pull and tidy the data from all the switches, I was like, yes, please. So they actually built out an entire IT network that was enterprise grade. And what you see is like in the late 90s, there was the development of what was known as the telecommunications network management layer. And this is how telecommunications companies acquired the data from every single cell phone, every byte that was going across the network, every send, every end, every drop call, because they had a series of aggregators that pushed the data into reporting databases or pushed it into real-time operations as data streams for immediate reporting. So I actually handed off the quote unquote data engineering portion of the job in the 90s. That meant there were people that could specialize in those data acquisition practices. And I was able to focus on creating the math behind the actual reports. So the fact that data engineering is only now coming into play, especially with questions around data quality management and data security, is about nearly 20 years past due in my world, or my ex world.
So on that front, there's certainly a business aspect, especially talking about some of these pretty large telecoms. There's certainly a business aspect to things. Can you speak a little bit about, is there a disconnect between the business and the data science?
You actually, that was, if there was, it had to be corrected, which is one reason why they created my position of core performance management. And in the RF side, they would have the RF people that did the KPI development. But again, our work was always peer reviewed. So we had to use statistics, which are now all rounded into that whole world of machine learning and all the fancy verbiage. We had to apply rigorous analyses, what counters we were going to use at what measurement intervals to be able to predict at least a 96% probability that we were going to have failures or drop calls. So everything had to be completely laid out, including the what was being measured, what the measurement interval was, how often it was going to be sampled, how many samples were going to be used. As a matter of fact, in the transition of technology, we moved away from a lot of the electromechanical measurements that had been available for the past 100 years. So like 100-second measurement interval. Now we started seeing measurement intervals that were, in the milliseconds. And so how do you handle the difference in the peak to average ratios? Those were high level organizational questions that had to be argued about and tested. And, you're doing analysis and presenting this data as networks are trying to go live or are live. So you were always having to document the full stream, including data source, and what the number actually meant. Sometimes when we deployed new technologies, we would have negotiated a counter that needed to be made available for a specific measure. But the first time you see the number, we're like, what's that number mean? And that kind of thing would go back to the developers. One of the most famous questions we kept having to push back to our counterparts at Ericsson or Alcatel-Lucent or Nortel or Nokia is, your counter itself says it's measured in kilobytes. Is that base 10 or is that base 2? Well, when your traffic volume is only in, megabytes, like the original over-the-air data network was, that was data over a 50 kilobit circuit, you didn't really see a big difference between base 2 and base 10. But now when you're talking about gigabit throughput, that difference in what the value that's being aggregated in became significant. And so being able to examine down to the minutest detail of how a counter was created was actually part of the job. But no one person could do the job. And that's one of the big problems I saw when I came outside of telecom into this world of data science. The data science jobs were end to end. They wanted people to do data acquisition, data cleansing, do the analysis, do the report creation, and the presentation.
Do you think that it'll become a team sport like that in data science? And Don brings this up, and that kind of comes back to that question about data engineering, and then breaking out feature engineering. Do you think this is going to become a team sport very soon in data science as well, like it did?
It has to. You cannot scale without it. That is exactly the reason why my story about my desktop was the server and I had to turn that over. You cannot scale with the growing volume of data with one person doing it. And you certainly can't reproduce it. You can't reproduce results if you've got everything on somebody's, cloud. So how do you organize data lakes so they don't turn into data swamps? And that's one big reason why I speak to the persistence and necessity of relational databases, because you can put data in there and it persists. You can find it again.
And you've listened to our podcast, it sounds like. And what's nice about your story is you've been in this industry that started up and it's evolved and it's changed, and you've gone through the entire life cycle of it, and it's been really fantastic, I'm sure. But you always hear, probably in the podcast, I ask these precautionary stories about what to watch out for, and no one's probably better to ask than you. It's like, is there any danger in what we're doing? Is there any precautionary story you could share? Is there any fear you have about where this is going?
Well, let me speak to you about, again, one of my past experiences, and that has to do with blocking probabilities. And you have a company, the ability to use an Erlang B table was literally that when I first started. There were books out there that, just like the log books, the book of logarithmic tables. So you had a number of channels and you had a blocking probability. You only wanted 1 in 10,000 calls to block. And you would look up, how many channels you needed to have for this amount of traffic. And then we had the first calculators. The first Erlang B calculator came from an Excel add-on that was used for call centers. But one of the things I discovered when I integrated that into my current business work was every once in a while I would get a dropout on the number. And again, this becomes significant when you're discussing modeling and performance expectations, where, if the city of Spokane loses its ability to make a wireless call at 2 p.m. on a Friday afternoon, who's going to pay for the outage? Or what about no data network available between Mexico and Canada for over a day? There's a lot of money riding on those models operating at the levels you specify. So whether or not you believe Poisson versus Erlang is the better algorithm, the fact is that we were working with Erlang B tables, so that was what we had to deal with. And the Erlang B calculator would drop out every once in a while. Now, whether or not that was a Windows problem, and I don't even remember what my computer was at the time, but that difference could become critical in how you engineered a network. When they finally had I guess it was an Oracle 12 databases, somebody finally wrote an Erlang B calculator that was a stored procedure so that you could actually run Erlang B calculations while you were creating your reports. It was a game changer. So companies like Algorithmia are like critical for people to be able to actually use a good algorithm and, come to a decision. Now, the fact is that you need to cross-check those numbers periodically. So even though I had an Erlang B calculator that was working in the stored procedure and I was happy with it, I would still go to like Tufts EDU site and check it on their Erlang B calculator. So it was always a matter of like, if you don't get the right answer, you need to act on that. You need to understand what the limitations are, but you should always be checking your outputs.
I feel like we could do a whole series with you, Andrea, and it would be really beneficial for people starting in data science today just to get a real perspective. I'd like to go back to earlier when you were talking about everything was peer reviewed and all the rigor that happened. And I wonder how much of this was driven by the peers, the engineers coming up with those processes, or how much of it was directed from on up. As you'd mentioned, you had algorithms reviewed, sounds like by Craig McCaw himself. Um, the the fluency of those executives, what was their tech fluency and how involved were they?
So I was McCaw, that was acquired by AT&T, spun off to Wireless, became, bought by Cingular, bought by SBC, renamed AT&T again. So there's a whole comedy routine on that. So what happened is that in the day there used to be regional engineers that took care of specifics, like for example, states. And so as through the different mergers, acquisitions, the different reorgs, you would have engineers that, I went from engineering ancillary systems in Washington to engineering systems in Washington, Oregon, and Washington, Oregon, California, blah, 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 blah. What made me successful is that I remained focused on trying to pull data together for insights. And that was one of the first things I did was actually pull together configuration data to be able to identify where software definitions were missing for hardware that existed or vice versa. And so by focusing on mashing together data from a variety of streams, my reports became valuable. And the way I put it is, I'm not a programmer, I'm a hack. And I don't mean hacker hack, I mean like I'm a hack. I know how to do a lot of little things to cobble something together. But what would happen is that in creating some of these reports, I ran into problems of, like I mentioned before, scaling. So other people would be brought in and they would take over my development.
And I think that it resonates, being able to assemble these technologies and make ration out of it. But another topic I bring up often is, the ability, and you mentioned explainability yourself. How well understood was the work that you did? Were you able to translate that easily into the business? And I mentioned that before, but did you ever have to operate in a vacuum for a while and come out of that?
Well, yeah, but the thing is like, again, so peer review was part of how the engineers worked together, which was looking at fundamentally, if your customers can't make a call, they're gonna be on you. And so the engineers that had the experience of trying to deal with a system that was under a lot of network load, we would spend a lot of time talking to each other and about trying to figure out what would be the best way to get the measure done. So peer review happened naturally.
Yeah,
but there were,
right? It has to happen, right?
Right. And the executives became interested in it when I saved them, $1 million growth jobs. You don't need this hardware because you have this capacity that's not defined, and you are not using the hardware that you've got in a rational manner. So, being able to mash up data from a variety of sources, and I was working with stuff. I mean, at one point we were crossing for one executive dashboard number, just one single number off of one technology, off of one vendor, off of one node, off of one type of processor in that node. I crossed 2 Oracle databases, SQL Server, and a Teradata database, pulling together configuration information. My fishbone was 11 layers long. I created something, I accessed over 20 tables. I created something like 43 different views and hundreds of columns of information for a single number. So tracing that and documenting that, creating data dictionaries, we had to, simply because we were creating so many measures for such a complex network. So actually one of the last projects I led on and left off at was the metrics inventory, the engineering rules database. And our engineering rules were integrated into AT&T's gold standards process while I was there, which meant that we had to document every single counter and how it was used and the math that was used. And that was entered into a database, because if anybody changed the software that affected the counter, you could have a red light show up on an executive dashboard. And, executives, when they don't sleep, they get cranky.
When I hear you reference Oracle, I just think Python sure could have helped you.
Well, I'm going to try to figure out how to put this nicely. One of the limitations of working for a very large corporation is that you are allowed to use, IT only allows specific software to be used and available on your workstation. And we were working with some of the world's largest databases. And so when I say Oracle, I'm talking about like an Oracle 8 database or an Oracle 12 database. And Python, I don't know where Python was in development in 2005 or 2009, but the nice thing about relational databases is that you have your data sitting in tables that are structured. So you might have, 100 or 1,000 different files, because we were dealing with like millions of records being created every single day back in the 90s off of one of our tables.
I mean, 2009, Google was hiring a bunch of Python developers. And what is your sentiment of the cloud and ML in the cloud? I mean, it seems like it was a counterforce to some degree of what you were working on, but was it an enabler, or what was it to
actually, it's one of the reasons that it drew me out of telecommunications. I mean, I was working with some very interesting data sets. The last algorithms I was working on negotiating were to be able to manage the IPv4 to v6 conversion, as well as the voice over LTE integration. So I was working on some big technology stuff. And it was simply because cloud computing was out there. And the first Kaggle competition is what raised my eyebrows, that there was actually sufficient open data to make that there would be some interesting problems to solve. And then Python having open source software to be able to, actually manipulate your information. And then the open source databases like MySQL and Postgres, they're what drove companies like Microsoft and Oracle to create the freemium versions of their databases, which became the reason d'etre for Visi Solutions. I was very interested in bringing my BI or data science, big data science, to small business and small medium organizations.
Well, we're coming up on time. I definitely love what you're doing with Afterwards. you want to share a little bit about your startup?
Afterwards is using big data to make a better cost of living calculator. And that comes from my personal experience that, moving to Georgia was not going to be 5% cheaper for me and my family. So selling my West Seattle home and moving to Georgia, it was not going to be that 5% promised. It was going to be close to $3,000 a year more expensive. And that's even if I bought a house that was only $118,000. I just am using open data and pulling data together so that we can help people uh, get what I'm calling an affordability number that's going to be based on things that will impact them the most. Housing costs that are market rate, not metropolitan averages. Property taxes that come from records, health insurance costs that are modeled and included, and then state and local income taxes applied to their income channels. So that's what Afterwards is, a better cost of living calculator for retirement planning.
A walk score for retirement, sounds like.
That's a wrap. Thank you for joining us on AI Podcast. You can reach us at ai-podcast.com or find us on Spotify or iTunes. Thank you again, and we'll see you soon.